Значит, кто не читал программку, сегодня тема у меня про обход в application firewall'ов, разных, интересных. Ну, сразу оговорюсь, что у меня задача была... Ясно. У меня задача была не столько найти обходы, сколько показать, как это можно делать, показать типичные проблемы, которые вызывают, собственно, те самые обходы. И вообще научить людей по возможности обходить фаерволы. Ну, в application firewall я имею в виду. То есть не дать какую-то конкретную в руки, так сказать, палку и сказать, она делает это, да, но научить работать с этой палкой, делать себе эти палки. Ну, грубо говоря, там, учить ловить рыбу, а не кормить рыбой. Но вектора, естественно, будут хотя бы как примеры. Поехали? Вот. About. Надо вставлять слайд такой. Значит, да, мы занимаемся аудитами приложений 9 года.
We do the audits, and we've been doing it since 2009. With our blog, my email, and it's my nickname, not the actual name that I have in my passport. So, pleased to meet you once again. What's web application firewall? What we need them? WTF, WAF, web application firewall to prevent the attacks, to prevent the application attacks. That's what we need it for. An attack is not a vulnerability as such. You do clearly understand that. That's the whole point. That's the whole idea. And the risk is not an attack. We had a round-table session yesterday, and people said, well, get rid of the most critical risks first. You need to be aware that the risk is not an attack, is not a vulnerability. You can create a serious attack out of smaller vulnerabilities. There are not too many risks visible, there are just vulnerabilities or just potential challenges may result in a bigger risk, but you are able to make an assumption that it can run a risk. So do please separate that. Risks and vulnerabilities and attacks. Software, web application firewall, hardware-based. Cisco with the ACE, which is a hardware firewall. And there are plenty of hardware and software WAFs. I'm not going to discuss their advantages or disadvantages. Whatever you use, hard or software product, there's the same logic. There's a web server which accepts the traffic, and apart from that, the web server could be self-written or somebody else's. If you buy a hardware solution, still there is some software running on it. The most interesting thing of an attack is the actual implementation of WAF. You all have servers, you have WAF, and you have to do something with the firewall. If it's overloaded, 90% of the hardware solutions, it's overloaded, you just send the traffic directly, bypass it, set an overhead. You can do it by imitating the DDoS attack, but that's not the most attractive option. You have to understand the difference between the web application firewall and application. It would not be that good to use this approach. Alternatively,
эксплуатации конкретного алгоритма.
you can utilize a certain algorithm, XML bomb, for instance,
Или какой-нибудь токенайзер. В общем, смысл в том,
or
что вы
tokenizer.
примерно
In other words, you understand what's the algorithm running, and you run a request that it's difficult to process, and the application is not going to work, and WAF is going to shut down or bypassed. This approach actually works because the admins don't want to share any responsibility for WAF damage. They want the traffic to be sent and the applications running, so the failovers are committed. It seems like that there is no major difference. If there is an alert about WAF shutdown, in terms of an incident, it's just an incident. It's all the same. So what's happening to the query? It should be passed. Data should be found, some protocol identified, and then a rule is selected by which URL will be identified, the host name, some more data, then it's normalized. Normalizing it. B64 decryption is running, or we analyze the XML files, do the detection logic. And then you state a verdict, whether it was an attack or whether it was not, after such an analysis. I'm going to show you some examples with mistakes and bypasses. The protocol level bugs look very much like abyss. They look like an abyss. Here they are marked in red. What's that? Parse HTTP packets. Ivan Ristic came up with protocol level evasions. And he was talking about the bypass of the firewalls. Your WAF protocol should be matching with the HTTP protocol used by application. If they are mismatching, for instance, bypass is created. Yesterday, I found it in one of the Twitter messages. Content type, you set it for invalid or multi-part. They use union select. If you remove content type, if you replace it for invalid, it cannot disassemble the packet, it cannot find the attack vector. It works in that way, so it doesn't really matter what kind of attack vector is applied there. It works as a transparent proxy. Here's a vector with a host name. You adjust it to a host name, a web application. So that the host name looks similar. HTTP parameters. Pollution, please read about that if you don't know. The use of the protocol when you name this parameter twice, ID equals 1, ID equals 2, and the application works with it in different ways. You assemble the attack from the blocks that have not been verified previously. The point here is that you parse the protocol twice. If it's parsed differently, you get a bypass. It is very seldom that WF is tuned properly in real practice, so I won't be talking about that. But as far as the other part is concerned, is the data normalization, of which I am aware and familiar with. Imagine there are no errors. You see a line, and here you can and should understand the attack vector. If it's plain text, without decoding, without anything, you may immediately start working with it. If it's encrypted and coded, you need to disassemble it, decrypt it. You should use the consultant services of those who specialize in that software and do the decoding. It looks like tunnels. Why does it look like tunnels? Because such an attack allows you to tunnel a format that you are utilizing. So it does not resemble abyss like in the previous case. But the tunnel should be pretty wide. Detection logic is not going to be used here. It will be bypassed. So it looks like tunnels. B64, XML, others. And the main idea is to check and verify whether the protocol is the same. Base 64. What's difficult about base 64? It's not a tree-like structure. It's something really plain. It's very plain. Don't know how to put more exactly. It's real simple. So where can we actually make a mistake? I'm not saying anything about XML here. We're not talking about the use of the looking for vulnerabilities. We're looking just for bypasses. Bypasses only. Here's another good example. Mod security. Here is a string base 64 decode will be checking for union select. Won't be able to find anything there. Union select fits into base 64 format. The application will be unaware of that. Base 64 decoding is running really well. It stops at the first equality symbol, and the application's base 64 may be implemented in a different way. It decodes everything. It does not stop at the equality sign, equal sign. To bypass that, you just send them the line. YWFN divided by mod security, and it will be using a different string, and there will be some bytes outside the mod security where you can hide attack mode. It doesn't really matter what you're going to put into that tunnel. Works like that. So base 64 decode X, that's what it's called. I've never seen it utilized by anyone. but it looks more like true. It decodes a little better. You can use it as it's the old bug, but we have decided to add just another function and not fixing the old bugs. Yesterday we were testing that, showing a few examples. In the XML format, the parser would disassemble the packet, but not XML, so they would be taking it as plain text. And we were using the same entities in XML. And we were replacing the U for the X75 code, which stands for the U symbol. They didn't know that it was XML, so it could not decode it, and the application would be parsing XML. And it was assembled from XML, and Union Select was working well. It was a good example of data normalization. Yet there is another problem. Those of you who know how to implement that, use it, but who's going to teach others the formats? Physically, you cannot do that. You cannot do that easily. You cannot formalize it, for instance, or you have to wait for an automated solution. How do you do it in an automated way? What do we do with the field if it works with two formats? For example, the IP JSON, you'll be attacked through XML. If you'll be covering XML, you'll be hit through JSON. So what are you going to do with two of them? We don't know. It seems like I've been talking I've been speaking very quickly. Detection logic. That's the main part. The part I had covered previously were non-typical bypasses, and now I'm going to show you the most typical WAF bypasses. Everything I'm going to be explaining is the WAF actual bypasses. Regular bypasses. You may want to bypass the non-regular solutions, and you can also bypass them using the same principle. Our WAF application recognizes every possible format. Ideally, it knows the data in this format, recognizes the data in all the formats needed, looking for strings and substrings, and is capable of actual work that WAF is supposed to do. It's not the only thing that it does. But anyway, it's just like ninja attacks. You'll have to be able to find a way to withstand those attacks. You'll have to be able to squeeze in like a ninja. There are some less universal, more specific vectors, and which will allow you to use the application, but for just one exact attack vector, and you won't be able to attack XSS through the same vector because it will require a completely different approach here. It's the less of an all-round solution, but it's a classic bypass that is used today. Detection logic. There are two implementations, with the exception of the suspicions of an attack, when you cannot clarify the type of the attack. Detection logic is mod security and tokenizers. What's the principal difference? Yeah, you may want to ask a question about the mode security analysis. The mode security analysis is used to search for input validation breaches, and they will not be speaking about the type of the actual attack. So we will not be considering it yet. We know how to bypass those. If there are scores, you need to diminish them, reduce them. If there are special symbols, you increase them. If there are some letters, the score is reduced. You just use fewer symbols if needed, or do without them. You can do it, but it's not detection logic, so we'll not be talking about that at all. So there are regulars and there are tokenizers. So what's a regular? A substring and a string, which extends further. It has wildcards, it has groups, symbol of the group, number of symbols, but you can set denials, regular assertion bomb, that's what we call it. When a string is selected, you see the regular expression. You set the string to make sure that the parser reads it for many times. Sometimes they have limited restrictions. The point here is the more frequent runs we have, the bigger the bomb. One string reading, you have many more. The more readings, the more the load on server, the higher your profit that you get in attacking. And tokenizer is what splits your string into more simple tokens, tokens of keywords, union for instance, or something else. It's not a regular thing. These are substrings, more simple ones, splitting bytes and groups without wildcards. Then it assembles the tokens. It's just like lexical lexical analysis is using this principle. Moving on. We'll start with syntax. Application firewalls need to block XSS attacks, most typical ones, but it's not a server vulnerability. JavaScript is a very flexible tool, so it would not make much sense to use regular expressions to protect against those. And the bypasses, they are real simple. You can easily Google them and start using them. Syntax is much more interesting because it's more limited. It's not dynamic language. It's a more formalized, like SEMAs, with no mistakes, but actually there are ones. As we know, between your application and a database, there is a protocol running with some specifics of data exchange, and the actual syntax can be varied. The syntax may be very varied depending on the database vendor. They may use regular expressions or tokens, but not taking that into account. It generates bypasses. I would recommend you to read those two works. One of them was created by Nick, who is delivering a report elsewhere here. We want to use fuzzing as the special byte fuzzing, looking for errors, mistakes. So the first work is a reference book for SQL parsers, and the second one is the Nick's work of lib injection. Now we're going to try and test it. What are you going to face? Delimiters in SQL expressions. SQL injection is an injection of operators. If you don't have any operators, you don't have an injection. The delimiters are required here, the splitters. In the first, we fuzz. The first option we fuzz with one, then space from. And the second line, union select from, and the third option version. We check for the bytes in between. Parentheses, and the fourth option is approximately the same. We just frame it with the symbols, and the comment symbol is the last one. This syntax and the last string will be valid when P5 stands for a comment symbol. You can fuzz longer ones, it just requires more time. So MySQL, as you know, is a classic case. The U group is the symbol which does not always stand for spaces. It's a special Unicode space which works in SQL. And by matching /s, the attack could be implemented. I just checked and verified the Bochum results, and those were just one byte combinations. You may combine it slash, asterisk, asterisk, slash, and it could also be dividing the operators as well as the parentheses. But just simple metrics are enough to bypass everything. Most interesting part starts. The function, the version, back quotas, shell, and MySQL is the symbol for a comment. Everything which is you may use parentheses by using reversed quotes, reverse quotation marks, and find for the double dash, find the double dash, for instance. That's the most interesting part starts. What can we do with syntax? Syntax MySQL, it splits into tokens, then it tries to create its own logic. The logic is strange, and it allows you to create queries, complete queries. And I wanted to fuzz something. The O group without the space, you select it, and this group contains almost all of the operators, and the @ sign, tilde is the module, exclamation point, negation, plus minus is addition and subtraction. You can insert a full stop, dot, it's a normal syntax in SQL, or E symbol, for example, 1E1 from, whereas 1 from doesn't actually work, whereas 1E1 from works. It was fuzzed when we did the bypass of our algorithm. It was fuzzed from 1R dot. We did it last year. We found a very interesting /n vector, which is a real brain damaging thing, because and from, that's what you result in, the word. You can do the variables. Here are very interesting vectors. You can take an ID, for example, select minus ID minus 1 dot. It will subtract 1, and there will be no space between select and from. So you will bypass the regular one. A simple, nice-looking bypass. @, which stands for a variable, and this variable may stand without time set.
делать. То есть, если кто-то написал регулярно, что ловить там переменные, назвал его собачкой что-то дальше, он ее не поймает, потому что...
They won't be able to trace it and catch it because it's not a variable, but it actually gives itself away as a variable.
Глупо было делать это на одном каком-то варианте, и...
Postgres.
Чтобы было понятно, чем мы вообще занимались, похвазили еще Postgres абсолютно так же.
Postgres
уже и пропадает из разделителя, самое пресловутое А0, у него все четко пропадает.
Is no longer here. It's it has been left out. No one knows why. It seems like there was just the same SQL syntax, but there is no 0 here. So what are the results? You can put the double quotes and function. Double quote is used for dividing. You can end the line also with the double quotation marks. There are no problems with that, but not so many people know about that. Regular expressions, select from, in quotes, and double quotes could close this comment. It's just a text comment, SQL request. Comments are crucial, are very important. The functions inside the injection. So now the tokens. There is an @ sign in Postgres when you just stipulate @1, @-1, in Postgres it's -1. It turns out to be even more flexible. You can not even translate anything. You just do select -1 and it will work. The token will find the number and the operator will be divided, so this request will go into the base. Check it if you don't believe me. The Postgres numbers are here. You see the first one is even easier. The first one from select one from test. Don't need to have any division number, division symbols here. You can use a tilde, or for instance, there's a -1, -1, and you get the idea you wanted to get. We have tested that at the Postgres at the recent version, and it works. But it also supports the older versions as well. It's not actually giving the vectors, but it's actually showing what we need to do to find those vectors. Time to exploit. What can we actually put in the SQL syntax so that it's not readable but it's executed? But it's not the point. How do we use it to exploit the engines that use the web application firewall, mod security, injection, some others? Mod security. As for mode security, mode security is the pioneer of all of the WF. It's a good system based upon regular expressions and heuristic metrics. It has role sets, and the role sets, by the way, mod security is free of charge. And the role sets are split into base category. They are free of charge. There are plenty of rules split into groups, and every file has got their own group. They have plenty of isolated files. There'll be regular expressions, so many. I will show you some of them. Base rules are sold. There are approximately 16,000 base rules. I've never bought them. I don't know what they're about. They describe the exact vulnerabilities, not the type of attacks, but the actual vulnerabilities. For PHPMyAdmin, for instance, there are specific rules of how you should not be using it. In other words, it's virtual patching. When you try to close the specific attack vector, it's called virtual patching, and specific rules are applied there. It's good because you spread the rules for a certain set of vulnerabilities, exact ones, and you set base 64D code. You know the exact vulnerability, you know the exploits, and you create a good rule for that. No one does that, and the basic option, so everyone wants to bypass it. Mod security has plenty of rules. It would be stupid to bypass them all, because no one has ever put it with base rules. Just use mod security, then there are plenty of false alarms, and they start to bypass it.
Значит, править это очень сложно, как вы понимаете.
It's difficult to change it. It's difficult to even read what's written there. And we've gathered the information select ID from test regular is based upon the word select and upon the word from. Of course, we did not fit the entire line here, it's too long. We remove the dashes, we remove the spaces, and it goes through and it fits all the rules. I've created some abstract rules about how it detects the exact string. So it's obvious what you do here. Here's the Darwin test, typical attack. 1 equals 1, so they decided to change it, change the vector. 5 equals 5. Then normal rules appeared, yet plenty of them operate on 1 equals 1 rule. Now we can attack mod security through 1 ort rule, ort true, in other words. So it's always true, and you can bypass the authentication, and it limits your selection, and you would like to expand this selection and put it down, or 1 equals 1. Or 1 equals 1 is intercepted, or 1 equals true is not intercepted. This is the rule. Very convenient to use. Now you know what you can charge this money for and sell it. You can put it into report, for instance, reported that you have sold 5 of those. Lib injection. Lib injection is an interesting topic apart from enterprise, WAF breaching, because there's nothing interesting about enterprise WAFs. You can breach them in no time. So lib injection and mod security are 2 excellent, interesting agents. R&D, there is also one, but there are plenty of mod security rules that people use. Some of them are faster, some of them operate more slowly. In actual fact, they create the same problem, so we have no other ones with the exception of those two. Lib injection. What's lib injection? As I told you, it's a tokenizer. It splits everything into tokens. And out of those tokens, it creates a fingerprint. From 1 to 5 consecutive tokens in a string. Of course, it would be stupid to use it bluntly and blindly. So there is a unique fingerprint containing 5 symbols characterizing the token they have met, so it intercepts the injections. There are 14 token types. The token type is a type of a token, the operator O, number with a number sign, comma. There are other tokens, union with a capital letter. So there are 14 base types. It's a very fast solution.
16 тысяч регуляров кто-то должен обработать.
It processes 16,000 regulars, but this one is a much faster one.
И всего существует по понятным причинам.
And you know that there are approximately 580 possible attack signatures. There can't be any more.
И это, теперь интересная задача, можно ли это проэксплуатировать?
Can we actually exploit it?
Этого предела теоретического 580 тысяч.
Is this limit of 580,000 fingerprints enough to cover all of the injections?
Сейчас около, чтобы не соврать, 2000.
Today we have approximately 2,000 fingerprints. But what about 500,000? Will it be difficult to bypass them all? We'll have to throw away at least one of them. So will we be able to force it? By the way, this product has just been released. It's a library which is free of charge. It's a new one. It's not a regular one, which is cool. It has been described just next door, and it's a very strategically appropriate library. This library cannot be attacked through fuzzing of just one byte, because it's not a token. Some tokens may be left out. It's a typical attack. For example, if you forget to give a proper description to the token, it will not have the fingerprint. Lib injection is an interesting thing. It's the future of the mod security. Mod security officially announced that the future version, instead of the regulars, it will have lib injection, which is good and cool for our ideology. So lib injection. The first attack, we fuzzed that there was a byte reversed quotation, reversed quotes, MySQL into out to file. No special tokens, just regular ones. At the comment part, you encounter a few problems. You may put a file with a random postfix, of course. So what we try to do is bypass the signature, and the signature S, KKSC, token, S space. S stands for quote, space is an N, KKS, ISD in quotation, quotation marks, token. Looks like that. So that's a fingerprint. Backquote N. It doesn't have such a signature, so syntax is not different from one another. Into out to file we would have quoted, but here we have a different engine. We have different problems which we need to be aware. And the second interesting attack that could be exploited is token obfuscation. We have data with bytes, at the bytes that can help you do the logic. Here, the tokens, you need to obfuscate the tokens. There is a limitation. Only 5 tokens make a fingerprint. To bypass this, you just need to fill it in with 5 tokens and throw in our rules.
вправо определенно будет
everything which will be on the right hand side here will be
может быть очень много в запросе. Это 5.
running as a bypass.
Исчерпан. Вот атака исчерпать эту длину 5, будет длина 10, будет
We just need to exceed the size of 5.
будущее развитие этого проекта, как грамотно группировать эти.
And the future will be addressing the proper arrangement of the
Нам
tokens.
нужно эксплуатировать
We need to exploit anti-obfuscation logic, the rules by which you group the tokens. Some of them are easier to deal with, some of them are not.
одна кавычка. Все равно.
If there's a string, for example, they accept it as one single token.
Именно от этих атак избавляться, но по понятным причинам в силу
What they do here is avoiding the attacks,
большой возможности синтаксиса и слишком мало ограниченной возможности того, что сейчас написано.
but there are limited capabilities of lib injection. We just need to bypass that logic and use different groups of the tokens to fill in the entire fingerprint
которые не являются
with operators,
не входил в наш черный список.
so it does not belong in the blacklist.
И потом уже дальше запихать туда все, что
And later we add everything we want to, because they won't be verifying it. They'll be making a fingerprint judging by the left hand side. Variables, those variables that I may set A1, 2, 3 and 4
как сигнатура V
is set as the
она определяется как сигнатура V.
V4
То есть он видит,
variable
туда все ты
signature. It's variable,
пиши после юниона и дальше, она будет после моей V.
and after V they will be
Соответственно, 4
putting everything in the fingerprint. 4 cells,
заполнить все эти ячейки, соответственно,
just 4 of them, but it's not the actual case. You need to fill in all of the cells.
можно, но Libinjection что про это ничего не знает. И, соответственно, он расщепляет уже ее...
Lib injection splits it to different tokens,
Раз, два, три, четыре, да? Вот.
V and 4.
Важно. И, соответственно, получается что мы закончили все. Мы закончили.
For
Мы
once.
всю его fingerprint. Мы запилили весь
And
его
we
участок.
have so far filled the entire fingerprint, and now we can use everything from the right hand side. Union select, for example, if there is a logic V and ID equals variable union select,
Вот этот injection, он ничего не сможет сделать.
lib injection won't be able to do anything here.
Естественно, единственный bypass, который там был найден, но
It's not the only bypass
опять же говорю,
that was
что
found,
bypass в концепте,
but it's not the matter of bypass, but the actual concept of how we'll be using these bypasses and looking for those bypasses. Our NSEC statistics, we have been breaching the WAFs since 2005, breached a number of implementations, 50 of them actually, 50 unique applications on 10 different engines, enterprise level, mod security. Those were engines, and there were plenty of enterprise products, and there were plenty of homegrown products created to protect applications. There were 50 of those, 10 different engines, and the minimal time to hack created by JustWave, minimal time to hack, which was promoted last year. Time to hack is a metric which they introduced. The whole point of the time to hack metric is that any security can be breached or bypassed, and you don't have a magic shield or magic protection. It's just a question of time, how much time you have to do away with the vulnerability, and this time is actually equals time to hack. 10 engines, 50 implementations, 3 minutes. Minimum time to hack, maximum time to hack is 19 hours. Average time is the working day, business day, 10 hours. But a very average time to hack is 1 hour, so there are plenty more of bad engines than good ones. Average time to hack is just 1 hour. And now I'm going to make a summary of all that story. We would like to do something different. We would like to create an engine which is principally different from everything else. With questions, please contact me by email. Those of you who came up to me with questions about the dog, please follow up. I will take a few questions. Thank you very much.
Пока мы ожидаем наших следующих докладчиков, есть 5-10 минут задать вопросы Владимиру. Можете поднять руку, либо подойти к микрофону.
Здравствуйте, меня зовут Владимир. Вопрос. Вы не проводили ли какие-либо сравнения коммерческих продуктов класса WAF? Какие из них работают наиболее эффективно?
Вот, к сожалению, enterprise продукты все работают одинаково плохо, и их просто сравнивать нечего. Но есть работы, не наши, там, недавно была опубликована работа, могу дать ссылку, сейчас в память не вспомню, ребята купили все, что можно купить в клауде, подешевле, и бесплатные продукты. Оказалось, что самый лучший из них mod security по детекту. Это сделали ребята до нас, вот буквально там за полгода, ну, даже меньше, 3 месяца, может, назад. Найдете, нагуглите, напишите WAF Comparison Test 2013.
Спасибо.
Да не за что. Это был, по-моему, с mod security. Нет, точно mod security.
Yeah, I think that was mod security. I'm certain it was mod security, but they got a component there. Well, essentially, it was a very well configured mod security, straight from the manufacturer, fine-tuned for a specific application. Well, if they don't send normalized traffic to the backend, then just your application is going to run. Well, just take an Nginx and see it in proxy mode. You see what it does. It essentially normalizes traffic, but it essentially sends the stuff in original mode. Essentially, if you found the vector attack, you cannot take it out. You cannot carve it out from the response. Because if you do it, it simply is not going to work. Nobody can really guarantee going to preserve the logic of the application. This is just way too risky. And this is why we have products like mod security, which you can install as a module on top of the application server to make sure that you don't send the traffic through a specific standalone part of hardware. But on the other hand, it essentially means that throughput is going to be low, so we have to multiply the number of app servers. The easiest approach is essentially to install more of these shebangs, more of these doodads.